So the first way we're going to learn how to solve linear equations is by graphing. So when you are looking for a solution to a system of equations, you are trying to find the intersection of the two lines. That's the goal. So what we're going to be doing is graphing both of these lines to figure out where they intersect. So because these lines are not in slope-intercept form, it might be easier for us to just make a table of values. So let's start with the green line over here. We'll make a table of values for x and y. Now remember, you really only need 2 points to make a line, but maybe it's important to do more than 2, but for now, I'm just going to use for 0 for x and then 0 for y, because I feel like the y-intercept and the x-intercept are probably the easiest parts to graph. So when x is 0, what we're looking at is 0 minus 2y is equal to 2. So let's just put that on the side. I won't do this every single time because I think that you will see what I mean. And we divide by this, we get negative 1. So the first point that we can graph is 0 comma negative 1, which would be right here. The next point that we're going to graph is the x-intercept, which is when y is 0. So we'll say x minus 2 times 0 is equal to 2. X minus 0 is 2. X is 2. Done. So then we plot the point 2 comma 0 right here. So because there is exactly rising 1 and running 2, we can see that this is going to end up being the slope of the line as well. But again, you don't have to do that, but I like to just finish up the rest of the graph. Sometimes it's not as obvious, especially when the points are so far apart. So this is our first line. And since we're really just trying to solve for the system of equations, we really don't have to label this line. Okay, so the next line that we're looking at is the x plus y equals 5. So we're going to do the same thing where we set the x and y intercepts here. So when x is equal to 0, y is equal to 5. And when 0 is y, then 5 is also x. So that was really interesting because you can see that 5 plus 0 is 5 and 0 plus 5 is 5. So we'll plot up 1, 2, 3, 4, 5 right here. And over 5, 1, 2, 3, 4, 5 over here. So you'll notice between these 2 points, it's a little bit harder to see what the slope is. But if you connect the dots and then extend it, we will see that they intersect right here. And so the answer is the intersection. And this is the point 1, 2, 3, 4, comma 1. So the answer to question 1 is 4, comma 1. For question 2, we're going to do the exact same thing. We're going to take the first line and the second line and create that table of values. So for the first line, we'll just set up our zeros because that's always the easiest thing to do. So we'll plug in 0 for x plus 3y is 3. So then we get 3y is 3, so y is 1. Then we'll plug in 0 for y, so we get x plus 3 times 0 is 3. X plus 0 is 3, then x is 3. So now we're plotting the point 0, 1 and 3, 0. So again, you'll notice here with this point that they are really close together, so you can count the slopes to help you graph the rest of the line. You don't have to do that. You can just draw a nice straight line between those 2 points, but for me, especially when I'm working on the computer, it's a little bit harder for me to plot straight lines. Okay, now we'll do our second line. So that would be negative x plus y is equal to 5. So let's plot our zeros. Negative x plus y is 5. That means that y is 5. And then negative x plus 0 is 5, means that negative x is 5. but that implies that x must be negative 5. So we're plotting the point 0, 5, and negative 5, 0. Again, it's kind of hard to see, but I can kind of tell that this would be the correct way of drawing the line. And the intersection is right here, which is the point negative 1, 2, 3, 2. If you don't state the intersection point, you're going to lose points on the exam, because just because you're circling it doesn't mean that you understand that it's negative 3, 2. Okay, we have our next one. So the yellow line is not in y-intercept form, so we'll start with that one. But the purple line that I highlighted actually is in slope-intercept form, so we can just plot that one without making a table of values. 4 times 0 minus 2y is 6. So negative 2y is 6, then y is negative 3. 4x minus 2 times 0 is 6. 4x equals 6. X is 6 over 4, which is, a little bit weird. So maybe we don't want to plot that point. Maybe we can try a different one. So instead of using 0, maybe we will use 6 over 4 here. Let's use 1 for y. So 4x minus 2 times 1 is 6. 4x minus 2 is 6. And now we're going to add 2 to both sides, so we get 4x is 8. Now this is going to be a nice whole number. So we're not going to plot this point right here because it's kind of nasty looking. Instead, we're going to plot 0, negative 3. And 2, 1. Okay, so it looks like we might be able to make one more point so we know where we're going. We're going up 1, 2, 3, 4. 1, 2, 3, 4, and over 2. So here is our line this way. Okay, now the purple line is already in y equals mx plus b, so we know that the y-intercept is negative 3, and we're going up 2 over 1. So this is very interesting because this is actually creating the exact same line. So since it's the exact same line, we can say that there are infinitely many solutions. That's the phrase. Number 4. So we have 2 lines here. So it looks like that the yellow line is already in y equals mx plus b, so we're going to plot that right away. We start at the y-intercept and go up the slope, and then follow down the other way, just so that we can connect the dots nice and easily. The purple line is not in y-intercept form, so we should definitely make our table. 6 times 0 minus 2y is negative 6. So negative 2y is negative 6, then y is 3. And then 6x minus 2 times 0 is negative 6. 6x is negative 6, so x is negative 1. So now we're going to plot the point 0, 3, and negative 1, 0. And then we're going to see that these two are exactly in a good slope here, so we can plot the same slope. And you'll notice that these lines will never touch. They never intersect. So if two lines never intersect, we would say the phrase there are no solutions. And that's it. Let's continue. The yellow line that I just highlighted is already in slope-intercept form. So let's plot that. We're starting at -6 and going up 2/1. We will connect the dots as best as you can. And the second line is not in slope-intercept form, so let's make a table of values for our intercept here. Now, you'll notice that when you plug in 0 for x, you also get 0 for y, and you also get 0 for x when you plug in 0 for y. So that is pretty terrible because it's only giving us 1 point. So that means that we have to try another point because we always need 2. So let's let x equal 1 just because, you know, sometimes it's easy to do that. So then you would subtract 1 on both sides and you get 1 comma -1. So now we can plot that point, which is here. So now that's showing me that we have a down slope just by 1. And we can follow it up the other way and connect the dots. And it looks like these lines intersect exactly here, which is the point 2 comma -2. Okay. We have 2 lines that are one's horizontal and one's vertical. So it's important to graph them, but you're going to see that it's very obvious what the answer to this one is. If x is equal to 3, that is every single time we have x is 3, y can be anything along that line. Similarly, y is equal to -2, you go to the -2, and now y is always -2, so we are on this line. And you'll see their intersection is right here, which is the point 3 comma -2. And you'll notice if you look here, if x is always going to be 3 and y is always -2, obviously that would have been the solution.